This is our last topic in our crash course in JavaScript. And arrays are used a ton in JavaScript. We already saw a little bit about arrays when we were learning about JSON the other day. But today we're going to focus on all sorts of stuff with arrays and bring in the other concepts we've learned about this week. So first things first, how do we create an empty array? And the way we do that is we're going to use fruits. So we're going to make this fruit focused. Let fruits equals open and close square brackets. Okay. So a little bit different than Java, right? In Java, when we do array literals, we use square brackets for indexing, but we use curly brackets for the literal, right? So that's a little inconsistent. JavaScript, square brackets, nice and consistent. That's how we create an empty array. We can also create an array with elements from the start. We can use an array literal. So create an array with elements. And that we don't need to redeclare fruits. We already did. So I'll just say fruits equals square bracket, apple, banana, cherry. And elements in our array are separated by commas. So other than the square versus the curly thing, this is pretty consistent with Java so far. I guess one big difference, though, or a difference I want to point out is notice that again, JavaScript isn't typed, right? Isn't strongly typed, rather. So we don't need to specify the type or use the square brackets next to the type or the variable to say it's an array. JavaScript just figures out it's an array because we assign an array to it. So that's a little bit different. But here's something that's similar or the same. Arrays are zero indexed, just like almost all programming languages. Console.log, we can say fruits subscript one, fruit sub one with the square brackets. And that will display banana. So apple is at index 0, banana is at index 1, cherry is at index 3. Continuing along with this theme that JavaScript is very flexible, unlike Java in many ways, elements can be added to arrays. That's kind of cool. This is unlike Java. So we can say fruits sub 3 equals date. That is totally fine. And then we can say console.log. Whoa. Console.log fruits. And JavaScript will display the contents of the array fairly nicely. Yeah. Yeah, great. Really good question. So here, let's run it and we'll try it out. So I'm going to run this first, and we're going to see apple, banana, cherry, date. That's how JavaScript formats it. We like that. Let's change it to fruits 10. So we're skipping over a bunch of elements. And let's run that. See what it did? So we can jump way ahead, and the elements that we haven't specified are just empty. So we could also say like console.log fruit sub 8 and run this. And we'll see that it's specifically an undefined value. So, but doesn't generate an exception. That's okay. Yeah. Also static. Oh, like in the square brackets, you put a string. Oh,
and it just kind of works.
interesting. I didn't know you could do that. That's cool. Why do people use what instead of JavaScript? Um, because having it strongly typed is nice. It helps us avoid mistakes. A lot of it is historical. So it's not like different programming languages tend to be more applicable for certain applications, right? Like we talked about at the beginning of class, Lisp was like for AI, right? I mean, not so much anymore, but at the time, um, Python is really popular for like data analytics and machine learning. There's a lot of Python stuff going on there, right? A lot of stuff is written in C++ plus plus for like lower level system software, robotics, things like that. So like everything's a little bit different. I think Java still has a little bit of a handhold on um, introductory computer science courses, as well as like business applications. There's still a lot of Java stuff out there, but you don't see as much Java for web applications, which is why we're focused on JavaScript. All right. That's a cool example. Okay, I'm gonna leave that in the notes. Um, we can use dot length to get the number of elements. So we can say fruits, or here I'm going to say console.log fruits.length. So that's similar to Java. Hmm. I predict it's going to say 11. Let's see what it actually does. It does. Okay. So it counts the number of elements, even if those elements are undefined. Cool. All right. So that's pretty similar. Here's a difference with Java. Elements can be of any type, unlike Java. I guess I wasn't really good here. This is like Java. Um, this came up yesterday, if I recall. Great question about like, can we mix stuff? We certainly can. So let's make a new array. And the first element could be a number. The second element could be the string. The third element could be a Boolean. The fourth element could be an object. The fifth element could be another array. And that is completely fine. And we can display that whole thing on the console. So a lot of flexibility with JavaScript. Yes. What's that? Um, the advantage of using TypeScript is it is type safe. So it's harder to like make those types of mistakes. But TypeScript is also compiled. So there's like an extra step. So you got to compile it. It's harder sometimes to get TypeScript to work in terms of different installations and tools and client side and server side. The bus app is actually written in TypeScript. And there's some weird things we have to do to get some of that to work in certain places. So it adds a level of complexity, but it provides a level of safety. So no, TypeScript is very popular. Yeah. Um, not I, maybe I'm not sure how to do that in one line of code, but you could make a new empty array and then you could initialize something at the end. But what would be the benefit of doing so? Because you can always change it later. Yeah. So I think normally we wouldn't bother, and then we just add more elements where we need them. So, um, oh, I actually had an example of this. All right. Well, I'm going to skip over that because we already got that. We have it here, which is fine. Um, all right. Let's look at some other methods on arrays. Arrays have methods like stacks and queues. So tying this back to what we've been studying this semester, we can use push and pop to treat an array like a stack. And it is fast when we do this, okay? Just like, we talked about the performance advantages of a stack in certain situations. When we use the push and pop methods in JavaScript with an array, we are going to get that same type of like very fast performance. So we can say things like fruits dot pop, and that will remove the last element. We can say things like fruits.push, and we can add elderberry or whatever you want. And we can add the element to the end. And then we can log this and see what that looks like. So we popped date off of the stack. We pushed on elderberry. Both of those operations will be very quick. So we don't need a different class in JavaScript. If we want the benefits of a stack, we just need to use the appropriate methods with the array we already have. So pretty cool. All right. We can treat an array like a queue. We just change the methods we use. So we use .pop to remove from the head of the queue. Okay, same method. And we use .unshift, and that's slower because queues aren't necessarily as fast as, well, queues, when we use an array like a queue in JavaScript, it's not as fast as like using a linked list in Java. So we can use unshift, which is a little bit slower, to add to the tail of the queue. So let's see an example of what that looks like. So we can say fruits dot unshift apricot. Apricot? There you go. And this adds the element to the tail of the queue. And then we can say fruits dot pop, and that removes the element from the head of the queue. So in this model, the head of the queue is also the top of the stack. So we just got to keep that in that like mental model in mind. And now if we log this, we can see the results of those changes. So by using the unshift function, we added apricot to the beginning, the head of the queue. When we did pop, elderberry was there. Now it's gone. This adding apricot to the head of the queue is going to be slower than pushing and popping stuff at the end. You can conceptually, it's reasonable to think of a JavaScript array like a Java array list. Okay, very similar features, behaviors, performance, results, and things like that. All right. Enhanced for loops are a thing in JavaScript, even better than in Java in many ways. So we can use a for of construct. So we can say for const fruit of fruits. And then we could log each in turn. I love this syntax. I think of it in my head as like for each fruit of fruits. I think Python's better. I think the preposition in makes more sense than of, but no one asked me when they define the language JavaScript, but this will print out all the fruits. So we can see here, they're printed out one per line, apricot, apple, banana, cherry, and then all of our undefined ones. So this construct is super nice for iterating through an array, just like we've been doing with all of our data structures in Java. All right. We do a lot of stuff in JavaScript where we have an array of, let's say, values, but we want to turn them into an array of objects so we can do something more sophisticated with them, or vice versa. And so there's a couple of functions we use very frequently with arrays. So we're going to kind of incrementally work our way through this because it gets a little bit tricky. So we're going to start by just defining a function that will create a fruit object when passed a parameter, which is the fruit name. Okay. So the following function is used to create an object from a string value. Okay, this is super common. From a string value that will be assigned to the name property. So we're going back to what we did yesterday when we learned how to define functions in JavaScript. We start with the function keyword. We give the function a name, create fruit object from name. We specify our parameters, just one. I'm going to call it item. We use curly brackets for the body of the function. And what I want this function to do is to return a reference to a new object. And I want that new object to have one property at the moment, named name, and have a value corresponding to the string value that's passed as a parameter. And this is really easy to do in JavaScript, going back even farther to when we were learning how to create objects. I can use this object literal syntax. I've got my curly brackets there. I'm going to specify the property name, assign it a value of item, and that's all it takes. So this function will take a single parameter. It will assign that parameter to the property name inside of a new object and return a reference to that new object. All right, here's why we want this function. We want this function because we're going to use a function called map, which takes a list and takes an array and operates on that array. Do I want to write this function? We're gonna write the code together of what this map function does, so you can see it here in the notes, and then we're gonna comment it out because it's already built into Java. But I think it's really helpful to see and visualize what it does. So imagine we wrote our own function map, and it takes a single parameter, which is a list, an array, and it's going to return a reference to a new list, a new array. And that's going to be the result of this function. So I'm going to create an empty array. I'm going to iterate through every element in the parameter list. So I can say for const item of list using that new construct that we used. And then we're going to build up a new array. So I'm going to say result.push. That's nice and fast. But I'm going to call the function that we wrote to convert from the string to the object. And I'll pass item in as a parameter there. And then I'll say return result. This code right here, we don't ever have to type again because it's built into JavaScript. Yeah. Great question. So the variable result is a constant, meaning the value of the result variable cannot change. The value of the result variable is a reference to an array. So we can't change the reference to an array, but we can certainly change the elements in the array. And because it's JavaScript, we can even make the array bigger and smaller and stuff. Yeah, great question. It's very similar. Like we could have a variable in Java that's final that like refers to an object. We can't have it refer to a different object, but we can certainly call mutator methods on that object. All right, so I'm going to comment this out by highlighting it and hitting what do you hit? Control / in VS Code, or on the Mac it's Command / Windows / on these keyboards. So here we go. So let's actually see what map looks like. But I want you to be able to reference this code as you think through in your head what is going to happen. So map is very useful for creating an array of objects from an array of values. We do this all the time. So let fruit objects, we'll make a new variable here, equals fruits is our array of all the strings of all the names of the fruit. We invoke the map function on the array, and we pass as a parameter a reference to the function that map will call. Okay. So our like pseudocode here is actually a little bit more complicated. Like list isn't really passed to map because we're calling it on the array. So that's already implied. And there's kind of an extra parameter here, which is the function we're going to call for each item. And then the result is what we push in the list. So I could probably make this pseudocode a little bit more realistic. But I still think essentially for this example, this is what map is doing behind the scenes. So now if I do console.log and I log fruit objects, we can see how it's different. So now it's logging the array, and I can see now it's an array where each element is a reference to an object. The object has a property name. They have different values. We still have 7 empty items, things like that. So kind of cool. Super, super useful. Um, Before we add a slight bit of complexity to this, what questions do you have now before we make it more complicated? All right, let's make it just a little bit more complicated then. Um, we don't actually use map like this. So arrow functions, so to go back to like what we're familiar with, arrow functions are typically used in these cases. We don't actually write a create fruit object from name function, okay? Here is the previous example using an arrow function. So the code we're about to type does exactly the same thing as this plus this, okay? But we're going to do it in a much more typical way that we will see. So we're going to say fruit objects equals fruits.map, so far the same, but then we don't pass a reference to, we don't pass a variable which refers to a function. We add the arrow function right here inside of the parentheses for map. So inside of the parentheses, this is where we put the arrow function. The arrow function is parentheses with the parameter name inside, which is item. There's our arrow operator. And then inside of here, we don't need curly brackets for the block. We don't need the return statement if we can fit it on a line, which we can. We can just use the curly brackets to create a new object with the property name and the value of item. And then we can say console.log fruit objects. This is exactly the same as what we typed before, but it's all done like in a single line of code. Okay. It will take some practice and some getting used to being able to read a line of code like line 70 and in your head realize what it's really doing is all of this on a line of code. Okay. But from like an efficiency perspective, once you do get comfortable with that, this is really convenient. That we can define the function using an arrow function and then invoke that map function as we want. So we can do, so this was an example of building objects. We can do all sorts of other things too. So here's some other examples just to show the flexibility. Let's make an array called cap fruits, meaning capitalized, all capitalized fruits. And we can say fruits.map. And so here we can define a map, an arrow function for each item in the array, map it to the result of item to uppercase. Look at how easy it is to iterate through every element in our array, perform an operation on it, building up a new array with that operation performed. So when we run this now, we can see all of the fruits are now capitalized. Super easy. Sometimes we have an array of objects and we want an array of just like values of some property of that object. So we can use the map function that way too. So we could do things like, or the other way around, we can do things like console.log. I'm just going to do it all on one line of code. Fruit objects dot map. All right, arrow function here, parentheses, arrow, return just the name. So this takes our array of references to objects. For each element in that array, it returns, because remember the curly bracket, the return is all implied here. It returns the value of just the name property and uses that to build up a new array full of that. So if we look here, it crashed. What did I do wrong? Oh, whoops. In the parentheses here, I need item. My bad. Let's try that again. Much better. Cool. So when I log the result of calling map on fruit objects to convert the objects just to an array of strings where the names are, here's the result right here. Super nice. All right, a couple more things that we are not going to go into, but as you practice the map function specifically, you will be able to apply your understanding of map to a whole bunch of other functions that are very powerful as well. And there are many other functions that we can call on arrays that do all sorts of convenient things. Many of these are going to seem familiar from like Python, if you're familiar with Python. So there are other array methods, such as, again, we're not going to do examples of all of these, but I want to share the names with them. So when you're like, oh, I need this, you can go look it up. Splice, slice, and concat are great. Very, very similar to Python. Index of includes, find, and filter. Index of is very much like Java. Includes is like contains in Java. Find and filter are more like map in terms of taking that arrow function. And then you can also have things like sort, split, join, and reduce. These are all great things. If you're like, oh, I'm curious about more of these, and I hope that you are. Oh, question first. Yeah. Here, really good question. Those curly brackets are not specifying a function body. Those curly brackets are being used as the syntax to create a new JavaScript object. So that's just shorthand for new object. The curly brackets say, make me a new object with a single property name and with the specified value, and return a reference to that object. So we're using it for object construction, not for a function body. Really good question. Why are we using map? So for this example, so fruit objects, let me run it so we can refer to the output. This is what the value of fruit objects is an array of objects. Each object has a property name, has a string value for whatever it is. What if we don't want an array of objects? What if we just want an array of strings where those strings are the names of the fruit? We don't care about the object. Maybe there are other properties in the object, like how many grams of fiber it has. I don't know. We don't care about that either, right? So this is a way where we can say for each item, which is a reference to an object, build up a new array where each element is just the value of the name of that item and ignore the rest. Map always creates a new array with some transformation based on the function we specify.